All right, today's November 19th, and we're going to be looking at 3.1.1 again today. This is part B. So this is our second day on exponents. We're going to spend 3 days total on exponents. Just a reminder, last time we talked about products and power to a power. I'm just going to write down some quick notes off to the side here to help us remember what those two things were. Products would be something like if I had x to the second times x to the fifth, what would that be? What is x to the second times x to the fifth? Would we add the 2 and the 5, or would we multiply? Add or multiply? Which one, Miles? What would I do with this 2 and 5? Would I add or multiply? Add them. So that would be x to the 7th. Thank you. And then the other thing was power to a power. If I had x to the second to the 5th power, this time we're not going to add. We're going to do what instead? What are we going to do instead of adding? Multiply. Excellent. Thank you. 2 times 5 is 10. Today we're going to be dealing with division. So what you're going to see today is we're going to have something like x to the 12th divided by x to the 5th. And we've got to be able to deal with stuff like that. We'll come back and write down our answer to this in a minute. Let's go ahead and flip to our next page. And before we get started, I'm going to ask you guys to review the work that we did last class. I know we did some of these in our warm-up quiz this morning, but let's do a couple more. Just make sure we're fresh with this. Could you guys just work the first 4 problems for me where it says warm-up here? If you get finished with those 4 problems, feel free to move on to simplifying the fractions down below, but don't go any further than that, please. All right, I'm going to give you about 3 or 4 minutes to do that, and then we'll come back and check answers. I'm going to run through these. Please check your answers. Ask questions if we need to. This would be a situation where we're adding exponents. I got 5x's and then another 3x's altogether. That's 8x's being multiplied together. I'm going to go ahead and do part C because it's also a situation where we're adding the exponents. This one has coefficients. Those big numbers are called coefficients. They multiply. 2 times 5 is 10. It's the exponents that add. So then I'll look and I'll see I've got 8x's here plus another 4x's here. That's 12x's being multiplied all together. And then I'll look at my y's. I like to put a 1 on things that don't have exponents. I've got 10y's here plus another 1y here. That's 11y's. So 10x to the 12th, y to the 11th. This is a situation where we're multiplying the 2 x's. I have 5 x's here, but there's 3 groups of 5 x's. So that would be 15 x's altogether. 3 times 5 is 15. Part D, we got a lot of stuff going on. My recommendation is if you ever run into a problem where you have stuff inside of parentheses without exponents, put an exponent of 1 onto it. So that 2 is 2 to the 1st power, and that z is z to the 1st power. My answer is going to have a 2 and an x and a y and a z in it. It's just the powers are all going to change. The powers used to be 1, 5, 2, and 1, but we're going to multiply each of these powers inside by this 3 on the outside. So 3 times 1 is 3. 3 times 5 is 15. 3 times 2 is 6. 3 times 1 is 3. And then one last step, we would just clean this up. What is 2 to the 3rd power? It's not 6. It's 8. Good. So my final answer would be 8x to the 15th, y to the 6th, z to the 3rd, and we're done. Does anybody have questions on those first 4? Excuse me. All right, let's review simplifying fractions. Your calculator will do this for you. I'd love for you to be able to do it without a calculator. But don't forget, your calculator does it. Can I borrow yours for a moment? The magic button on the calculator, if you would want to check, try and do them by hand, but if you want to check, the magic button is this N over D button here. So if I do 15 and then that button and 10 and hit enter, it will simplify that fraction for me. That's why I asked you guys to get calculators a couple times already this period. But if you don't have one, then do them by hand with me. The way we do them by hand is we ask ourselves the question, what is the biggest number you think of we can divide both 15 and 10 by? I'm thinking 5. They both divide by 5. 15 divided by 5 is 3. 10 divided by 5 is 2, so we get 3 over 2. How about 50 and 40? What's the biggest number you can divide both those by? 10 divides both of those. 50 divided by 10 is 5. 40 divided by 10 is 4. Twelve and 20 both divide by 2, but there's something bigger that goes into both 12 and 20. 4 goes into both of them. Anything bigger than that? 6 goes into 12, but not 20. 5 goes into 20, but not 12. I think 4 is as big as we're going to get. Dividing by 4 top and bottom is going to get me a 3 on the top and a 5 on the bottom. How about 8 and 14? First of all, before we get into what divides into both of them, tell me, is my final answer going to be a positive fraction or a negative fraction? It's going to be negative because a positive divided by a negative is a negative. So go ahead and put a negative in front of your fraction right now, and then we don't have to worry about pluses or minuses. We'll just think about the 18 and the 4. The 8 and the 14. What goes into both 8 and 14? 2 does. Is there anything bigger than 2 that goes into 8 and 14? 7 goes into 14, but not 8. I think that's it. I think 2 is as good as we're going to get for that. 8 divided by 2 is 4. 14 divided by 2 is 7. 4 and 7. Is there anything else that goes into both 4 and 7? I don't think so. Yeah, so 2 was it. What about part G? Is my final answer going to end up positive or negative in part G? It's a negative divided by a positive. If the signs don't match, it's going to be a negative answer. We can divide 18 and 27 both by 9. Divide by 9, we get 2. Divide by 9, we get 3. And then in the last one, negative divided by a negative is positive or negative for our final answer? This one's going to be a positive fraction. Let's see, 32 and 48. Those are both divisible by 2, but I feel like there's something bigger than that. 4 goes into both of those. Is there something bigger than that? How about 8? 32 goes into 8, or 8 goes into 32. I think 8's probably going to be our biggest. I think so. Ooh, 16? Does 16 go into both of those? You got a calculator in front of you. What's 32 divided by 16? I want to say that's 2. And is 48 divided by 16 3? It is? Oh, okay. So 16 goes into both of them. Now let's say I didn't get that. Let's say I first said 8. If I divide them both by 8, I would end up with 4 and 6. And then I would look at 4 and 6 and say, oh, wait, that can reduce even more. 4 and 6 can both be divided by 2. So we'd end up with 2/3. So even if we don't get it on the first shot, as long as we keep simplifying, we'll eventually get to the correct answer. Folks, you need to be able to simplify fractions today, okay? You need to be able to simplify fractions. If you can't do this in your head, then you need a calculator in front of you. Can you please get out a calculator or grab one? Thank you. All right. Just in case, I just want everybody to be able to check their answers. Even if you can do these in your head, you're going to be dealing with some bigger numbers today. I want you to be able to check and make sure you're getting the correct answers. Okay, here we go. I'm going to teach you guys about exponents with fractions today. We're going to start today the way that we started on Friday. Do you guys remember where I made you write everything out and was kind of annoying? You had to write out all the X's and stuff. I'm going to annoy you again today. We're going to write everything out until we figure out what the shortcut is, and then we'll simplify things a little bit. All right, so here we go. could you guys please work with me on number 1 here? This says x to the 6th over x to the 4th. So draw me a big fraction bar. Give me 6 x's on the top and 4 x's on the bottom. You don't need to put dots in between them. Just list them out. 1, 2, 3, 4, 5, 6 x's across the top and 4 x's on the bottom. 1, 2, 3, 4. Do you all know what we're allowed to do when we have factors that match in the top and bottom of a fraction? Do you know what we're allowed to do with those factors? We can cancel them. So like this x matches up with this x, I'm allowed to cancel and cross those out. These are going to cancel also, and these are going to cancel also, and these are going to cancel also. So how many x's do we have left over? 2. And on the top or the bottom, where are they left over? Left over on the top, so I'm going to have x to the 2nd. Now, I could write it as a fraction and write it as x to the 2nd over 1. If everything cancels on one side of the fraction, it's a 1 down there, not a 0. It's a 1. But normally we would not put that 1 on the bottom. We would just write x to the 2nd. All right, let's do this again here. I got 7 x's on the top. 1, 2, 3, 4, 5, 6, 7. 3 x's on the bottom. 1, 2, 3. We're going to start canceling and see what we got left over. How many leftover x's this time? 4 x's on the top. 4 x's on the top. So do you want to write it as x to the 4th over 1, or you just want to write it as x to the 4th? Let's just leave it like that. We could put a 1 on the bottom if we wanted to, but we don't have to. That rule is going to change in just a moment, though. I hope you guys aren't working ahead of me. All right, number 3. Draw me a fraction bar. Give me 2 x's on the top, 5 on the bottom. Do your canceling. And tell me how many x's are left over this time. See 3 leftover x's? Where are they? They must go on the bottom of a fraction. Now there's nothing left on the top. When there's nothing left, what do we put? Not 0, a 1. When everything cancels and nothing's left, there's still a 1 there. All right, that is the answer. In problems like this, we cannot leave that 1 out and just write it as x to the 3rd. That is wrong. Okay, it has to be 1 over x to the 3rd. So when there's a 1 on the bottom, we can leave that out. When there's a 1 on the top, we cannot leave that out. That's a super common mistake. All right. Let's do another one here. We got 1x on the top and 6 on the bottom. 1, 2, 3, 4, 5, 6. We're going to cancel and ask ourselves how many x's are left and where are they? I see 5 x's left over. Nothing on the top. What are we going to put on the top? 1. And can we get rid of that 1 and leave it out? How you guys doing so far? Has anybody figured out the shortcut to this yet? So we don't have to keep writing out all the x's. What am I doing with my exponents here? What did I do with my 2 and my 5 to figure out that I was going to have a 3? You were subtracting the 5 and the 2. 5 minus 2 gets you 3. Is that working for all these? 6 minus 4 got us 2. 7 minus 3 got us 4. You want to try using the shortcuts for the rest of them so we don't have to write all these things out? Okay, let's do it. Let's do it. You guys are brave. All right, draw me a fraction bar. And rather than write it out, this time I want you to imagine that I had 2 x's on the top and 3 on the bottom. If I started canceling, how many x's would be left over? Just 1, and where would it be, on the top or bottom? We would have 1 leftover x on the bottom, so I'm going to put 1 leftover x on the bottom. How about my y's? If I had 4 on the top and 2 on the bottom and I started canceling, how many leftover y's am I going to have? 2 leftover y's, where at? Top or bottom? On the top. That's it. You guys feel pretty confident with that shortcut? Now, if you want to, you can still write it out. We could have written XX and 1, 2, 3, 4 y's and 1, 2, 3 of these on the bottom and 2 on the bottom here, and then we could cancel some. I mean, it's kind of nice canceling. It feels nice. But we didn't need to. We kind of thought our way through to figure out that we'd have 2 on the top and 1 on the bottom. So see if you can do that on this next one. Try it on your own. Imagine you've got 7 x's written out on the top and 2 on the bottom. You start crossing stuff out. Figure out how many leftover x's are there, and which side of the fraction bar should they be left over on. And then do the same thing with the y's and see what you get. Try these next 3 on your own, actually. See if you can go up through number 8. All right, let me catch up to you guys. 6 and 2, or 7 and 2, there'd be 5 left over on the top. 3 and 5, there'd be 2 left over on the bottom. Number 7's kind of weird because I don't think there's going to be anything left over on the top. 2 and 4, so these are going to cancel. There'll be 2 leftover x's on the bottom. 4 and 1, there's going to be 3 leftover y's on the bottom. And this is the only place where a 1 is required. If everything cancels in the top of a fraction, we have to put that 1 in there. So that would have a 1 upstairs. Number 8 is also kind of weird. Let's talk about the y's first here. What happens when you have the exact same thing in the top and bottom of a fraction? The exact same factor in the top and bottom of a fraction? We can cancel them. This y to the 5th and this y to the 5th, they are exactly the same, right? If we started canceling, all the y's are going to go away. So we're not going to have any y's in our final answer. If we cancel the x's, we are going to have 1 x left over in our final answer. It'll be on the top. There's nothing left in the bottom, so I could put a 1 down there, but if we have a 1 in the bottom that's not strictly necessary, we could just call that x. You could call it x, you could call it 1x, You could call it x over 1. You could call it 1x over 1. Those are all correct answers. I like x the best. It's the simplest. All right, let's look at number 9. So when we start sticking these coefficients in here, nothing really changes. When I write my final answer, it's just going to have a 2 and a 3 inside of the fraction. Now tell me about my x's. When I start canceling my x's, how many x's am I going to have left over? 4 x's, because 6 minus 2 is 4. Where are those leftover x's going to be, on the top or bottom? On the top. So that would be my final answer there. So if we have a fraction, we just include it as part of our answer. The only time we have to change the fraction is if it simplifies. Is there a way to simplify 10 and 15? What can we divide both of those by? We can divide them both by 5, right? So what is 10 divided by 5 and 15 divided by 5? That would be 2 and 3. Again, if you're not comfortable doing this mentally, you've got a calculator that you can type 10 over 15 into, and your calculator is going to tell you it's 2 over 3. So 2 over 3 is going to be in our final answer, and then this looks kind of familiar, 6 and 2 again. That's going to be x to the 4th on the top, right? How strange. Is number 11 going to be the same answer again? Did you guys notice that? 9 and 10 were the same. Let's do number 11. Can you simplify 2 and 3? There's something that goes into 2 and 3 other than 1? No. So just leave it in there. How many x's are going to be left over once we cancel here? 4 x's on the top? This is getting kind of boring, guys. It's the same answer we've had 3 times in a row. I'm sorry. Is it going to happen again? Can I simplify 10 over 15? Yes, what is it? It's 2 over 3. All right. 4 in a row. I think that's it. I hope that's it. Yeah, because we're going to have y's in our next one. All right, let's look at 13 and 14 together. Help me out with 12 and 16. What goes into both 12 and 16? 4 goes into 12, 4 goes into 16. I think that's going to work, right? So 12 divided by 4 is 3, and 16 divided by 4 is 4. All right, focus on your x's. You got 4 on the top, 2 on the bottom. If we start canceling, how many are going to be left over, and where are they going to be? 2 x's on the top or bottom? Where are the leftovers going to be? More x's on the top, so there's going to be 2 x's left over on the top. What about my y's? If I start canceling y's, I got 2 and 5, so it's 5 minus 2 is 3. Are they going to end up on the top or the bottom? Bottom. That's right, bottom. Last one together, guys. Am I going too fast here? Are we okay? We okay? What's going to happen to this negative over a negative? It's going to turn positive. I just think of those negatives as canceling each other out. So my final fraction is not going to have any negatives in it. Help me out. What can I divide a 3 and a 9 by? Anything? Well, we can divide them both by 3, can't we? So 3 over 9 reduces. If we divide both of those by 3, we would get 1 over 3. If we start canceling x's, we've got 3 and 4. We're going to have 1 left over on the bottom. And if we start canceling y's, we've got 1 and 5. 5 minus 1 is 4. We'll have 4 left over at y's, but they'll be on the bottom. That's it. No x's or y's on the top there. And we've already got our 1, so we're We're good to go. All right, flip over and back. Now that we got the gist of this, let's get some notes down. So when we divide bases, what do we do with the exponents? What were we doing a minute ago with the exponents? We weren't adding this time. We weren't multiplying this time. What were we doing? We were subtracting. So when we divide the bases, we subtract the exponents. But we also had to think about whether it was going to end up in the top or the bottom. What was the rule for where it ended up? If I have x's in the top or the bottom and I subtract my exponents, how do I decide whether it's in the top or it's in the bottom? Guys, look at number 15 here and tell me. My final answer is going to have 5 x's, agreed? X to the 5th. Is it going in the top or the bottom? It's going in the top. How did you know it was going in the top of number 15? 25 minus 20? Okay, but what about in this one? Are my y's going to go on the top or the bottom? In the bottom. So how can you tell whether the x's or y's are going in the top, like in 15, or in the bottom, like in 16? What's the difference? Wherever the most are, yeah, wherever the bigger number of exponent is, that's where they're going to end up. So I don't know how you want to put that in words here. I'm going to write ends up where the bigger exponent was. I don't know if that makes sense to you. If it doesn't, put it in your own words. So when I've got a over b, you guys are saying that we would subtract. We would go a minus b. I'll let you come up with your own examples. Someone help me out with an example. Give me a couple exponents I can put onto these x's. Winter, what do you got? Give me a couple numbers here. Three and 5. That is an excellent example. I love it. 3 and 5. If we were going to do this problem, we would clearly do 5 minus 3, which is 2. And where would they end up? On the bottom, because that's where the bigger ones started. Should we do another example where the bigger number's on the top, maybe? That might be a good idea. Michael, can you give me a couple numbers with the bigger one on the top this time? 16 and 13. Another excellent example. 16 and 13. Love it. We can subtract those pretty easily. 16 minus 13 is 3, but this time those leftovers are going to go on the top. You know what might be a good idea on this one? Is to write down what the common mistake is. 1 over x to the second is not the same as x to the second. That is not correct. All right. So your job is to practice these a little bit. I would like you to at least, let's do this. Could I get you guys to focus on the left-hand column here? And if you can get through just the left-hand column up through number 29, we'll call it good. Finish those up, just that left-hand column. If you want some extra practice, you can do the even-numbered problems too. Let's focus on the odds for right now. I'll put answers up on the screen here in a few minutes so you can check. If you finish before I do that, Let me know and I'll get you started on the assignment, okay? Please let me know if you need any assistance with this for fun. So let's look at, actually let's look at 19. All right. So first I want you to focus on this 10 and this 4. Can you tell me a number that goes into both 10 and 4? 2 goes into both of them. All right, we're going to draw my big fraction bar here. Make it pretty big. If I were to divide both of those by 2, so the 10 and the 4, I divide them both by 2, what would I get? 10 divided by 2 is 5, and 4 divided by 2 is 2. Good. All right, you're doing awesome so far. Now we're going to work this out the long way, okay, and then we'll come back and talk shortcuts, okay? So I picked this one because there's not too many things. So can you go ahead and draw me 3 F's up top? 1, 2, 3. And then 6 G's up top. 2, 3, 4, 5, 6. And then look at the bottom. You're going to have a different number of F's and G's in the bottom. Do the same thing on the bottom. So you've got 4 F's and 2 G's on the bottom. Did you draw those in already? You did the 4 F's and the 2 G's already on the bottom? Okay, go ahead and do that. 1, 2, 3, 4, and then 2 G's. Okay. So in a minute we're going to come up with a shortcut, but this is kind of the long way to do it. All right, so the idea is if you have a factor, these are all factors on the top, and these are all factors down here. If you have a factor that matches on both the top and the bottom in a fraction, what are you allowed to do with it? We just cancel them. We just cancel them. So I'm going to cancel this F with this F. I'm going to cancel this F with this F. I'm going to cancel this F with this F. And then we've got some G's that we can cancel also, right? This G and this G can cancel. This G and this G can cancel. So far, so good? All right, you're doing great. We're almost there. All right, let's rewrite our next step. This will be our final step. We still have a 5 on the top and a 2 on the bottom. Now, I want you to look across the top. Are there any F's left over on the top? No F's left over at all. How many G's are left over up there? I see 4 also, so let's do G to the 4th up top. Look at the bottom. Are there any F's left over on the bottom? Just 1. Any G's? Nope, so just 1 F on the bottom. And there we go. That's our final answer. Okay. Now let's talk shortcuts now. Okay. Now you got the idea. Go back up to the top. Look at number 15. We're not going to write out 25 x's and 20 x's. I want you to imagine if I did write out 25 x's and 20 x's and I started canceling, how many x's are going to be left over? 5. Would they be left over on the top or the bottom? On the top, because there were more on the top to begin with. So 5 x's left over on the top. Everything on the bottom would cancel, right? When everything cancels on a side, we always stick a 1 there. Now, in a fraction, if we have a 1 on the bottom, we can just get rid of it. So x to the 5th would be our answer there. One more with me here, Caden. Look at number 16 with me. If I wrote out all these y's and I started canceling, how many y's would be left over on the top or the bottom? 7 y's left over on the bottom. And what do we put on the top since everything canceled on the top? 1. Now, when we have a 1 on the top of a fraction, we cannot just get rid of it. It has to stay there. So my final answer has to be 1 over y to the 7th, and that's it. All right, you get the idea? So we're basically just subtracting the exponents. You thought in your head 17 minus 10 is what gave you that 7. It was the bigger amount on the bottom, so that's where we left them. You got it? All right, you're all caught up. Congratulations. That was quick, huh? Yes? 27? Awesome. Let's look at 27. This reminds me of what we did on Friday. This is different, isn't it? So nothing's going to cancel here. We just need to go back to our shortcuts from Friday. So big coefficients get multiplied for 6 times 20 is 120. And then look at your x's. You've got a 3 and a 5. The tricky thing here is remembering, what do I do with that 3 and 5? Do I multiply them or do I add them? You add them. Good. And same with the 2 and 4 for the y. And that's it. Let me get you some answers so that you guys can kind of check. I'll zoom this out. And I'm just going to do answers to the odd numbered problems.